So now we're moving on to the casing. In the lathe right now I have 1-inch diameter nickel silver 752 alloy round stock. Nickel silver is more wear resistant than brass, but it's also more than twice the price of brass and very difficult to buy in small amounts. So this 1 foot section cost me about $80 to get it shipped here. I just can't afford to buy, 144 feet of it or whatever. So I haven't started drilling from the others, so we don't have to center it. So we're going to come in just with a 1/2 inch drill and plow through it, and then we're going to come back in with the 3/4 inch drill after that. I don't have flood coolant, so it gets hot and it's annoying sounding, so we're going to do our best to power through. We only got about 1 inch to drill in. We're drilling at 900 RPM because this likes to go fast. It'll actually break a chip. It drills like if copper and pewter had a child, it would be nickel silver. Really like similar to cast iron too, it just crumbles. But it's incredibly strong. Sound of victory. Change out my drills here. Yeah, so now this is a 3/4 inch drill. This will just take us up to where we need to be. 750. The final, I think the smallest section on the rotor is like 790-ish. So it leaves us about 40,000, so wiggle room to make some mistakes. I'm going to slow this one down. About 500 RPM. It's going to sound terrible right now, so brace yourself. See the chips are heating up quite a bit, so if this is actually a pretty good thing. We're losing a lot of the heat in the chips, but that rod is getting really hot. I'm not touching that rod, that's going to burn me pretty easy. Okay, so we got it bored out to our depth. We're going to off the rippings, and then we're going to come up, and this is 1-inch bar. The final dimension of these valves I'm making now is 15/16, which is 937.5. The reason I just use 1 inch is because you can't buy 15/16 unless you're buying from the mill, and even then it's probably expensive. But so I just need to turn down the surface just a bit, and that's good. Okay. So we're getting pretty close. You can see that surface finish is coming out really nice. It's pretty difficult to get so we're pretty hot. $975-ish. Yeah, we're warming up a bit, so I'm gonna take one more cut, and then I'm gonna let it cool down for a little while. Take it out of the collet. Just another 25 thousandths. Take away some more of that material. Yeah, this brazed carbide is from McMaster Car. It was like $7, and it's probably the best tool for brass, nickel, silver that I've ever used. Just leaving an absolute mirror. I don't even know if I'll have to sand these. It's pretty amazing. So I'm just tracking back over the surface because we're going to obviously come back and give it a little more work. So I'm just going to come in here with calipers and get a quick reference. Yeah. Of course they die, but 950-ish when I use my other ones. So we got a little bit to go. Not much. 940, 950. So I'm going to let this cool down and then I'm going to come back to it. I really need to do flood coolant, but this is a job better for a turret lathe. It's cooled off a bit. I just didn't want to get any bad measurements from it being inflated. So we're going to come in now with a mic. This dimension isn't really toleranced that highly. Actually, on the 1-inch valves that I do, which is equivalent to like a German 25mm valve set, I just use the mill finish and I just sand it once I have the blanks cut out. So we're looking 9, okay, yeah. So I'm going to do 10, break it up into 2, 10 and 10. I need to touch off. I'm just amazed at the surface finish I'm getting out of this tool. Much better than any high-speed steel that I've ever ground. Probably my shortcomings. I should not have backed off. So, let's see. We are like spot on. See what the calipers say? Nah, I don't need to. I'm just going to make sure it slips my collet. Yep. So that'll be perfectly fine. Yeah, I just want to make sure we can get a good hold on it. So all we're going to do now is we're going to come in, we're going to face. Tool's on an angle, so I don't want to do too much. That face is going to get redressed anyways. And all we're doing here is scribe lines. So we have one at 200 thousandths off this edge. That's going to be our gutter. The gutter for the thread is 50 thousandths in diameter, so the thread length is about 0.15. And then this is... Oh. That's the line for the length of our valve casing. So I'm going to grab my gutter tool. This is just a tiny little grooving tool. Like I said, about 50 thousandths. And I'm going to put it up to the edge of that first scribe line on the inside of that scribe line. And I'm going to touch off. Set my cross slide, and I'm going to go in about 45 thousandths. Right there. And that's just going to give us a place for our thread to drop off into once we thread the casings. And then we're going to part off here using that same tool. Actually, the nickel doesn't like this tool very much, but I'll roll with it. Usually I would switch to carbide to break that edge. Okay, yeah, that tool heats it up a bit, but yeah, so it's going to be pretty warm, but that is our casing blank. Doesn't look like much. So what we have is, it's just drilled out, and then we are going, the next step is to, not to thread it. I don't thread it before I braze it. We're going to drill the holes on the mill for the knuckle porting, and then we are going to braze in some knuckles. So that'll be a next video. Thanks for watching.